I think this is, the final expression. So sometimes they'll say that we want the seventh term. Okay, so they won't necessarily tell you which power or anything they're interested in, they just want a particular term. Oh, now it's remembering way back when we first started this. What did we say about the number of terms that were in this sequence? One extra. So in this sequence there would be 22 terms. Okay. So if we want the seventh term, what is going to be the value of r?
That minus what I equals 7, right? No, 6. You got 6.
Yes.
Yeah.
Yes. Why?
Because if it's like one extra, you don't want 8, and you have to have 17, 6.
Nice. We were happy with that. I'm not quite sure about the explanation. I understood it. What we have to remember is that when we are doing the terms, remember we're doing like NR each time. So if I were to start writing this, I would write 21. What value would I put on the bottom first? 0, yes? And then I would have 21, 1, 21, 2, etc., etc. But our first term would be where r was 0, and then the second term is where r is 1, so on and so forth. So if we want the seventh term, then that means that r is going to be 6. Yeah? And so then all we need to do is to stick it into the general formula. Now, this one here has got an x on the bottom. So as we did last lesson, we're going to change that to be a negative power. So this is going to become 2x squared minus, what would I do here? X minus 1, lovely job. Okay, that's good. Over here. So they want the seventh term. We've got alright, so I haven't got that thing saved anymore. So the general formula, you know what it is. Yeah. Oh, yes, nice. Okay. You're trying to Oh.
And minus r.
Nice. Do you remember how you saw it?
No.
Check you got out. Okay, so n is 21, yes? Oh my god, that's so good like n. R is 6. And A is, what's A in our one? 2x squared, and B is negative x and negative 1, transparent, chuck it in. Remember use brackets. Let's do this bit in our head, so 21 taken away 6 is, oh my god, oh, okay. And let me just write it. And then, yeah. I'm laughing, I think it's because I was right. Right, so the 21/6 is the 54264. Oh, blimmin' heck. Right, so we've got 2x squared all to the power 15. So what do we have to do here? Nice. 2 to the power 15, shows me out. Really?
No, don't you have to multiply it?
Now remember, we raise it to the power.
No, I was talking about the x.
You're talking about the power of x, yeah. But remember this number here? You raise to this power.
3, 2, 7, 6, 8.
3, 2, 7, 6, 8. So we can see my numbers. And then we've got x to the power of 30. That's what Malai said. Yeah? Yeah.
Wait.
Yes, I'm waiting. No.
Where did we get that number from?
This one?
This second number.
This is 2 to the power 15.
Gosh. Why did we raise it to the power?
Because it's in brackets. We did raise it to the power 30. It's, then we had x squared, which is also to the power 15, and when you do that, you multiply these bad boys.
Yes.
Yeah. And then our last term is this negative x and negative 1 to the power of 6. Right, it's a negative term. but we've got an even power, so we know it's going to be
Positive.
positive. And then we've got a negative 1 here and a 6 here. You just say numbers. So this is going to be x to the power negative 6. Yeah? Yeah.
Oh boy.
100% sure that any of the things that related to that. Yeah.
What's the trick for the power thing? Tell us negative or positive.
If this is even, then and this is negative, it's going to be a positive number. So if this is negative and this is 5, then it would be a negative value. Because if you've got like negative 2 multiplied by negative 2 multiplied by negative 2, these two here pair together, so that gives you a positive value, but this bad boy is going to change it back to be negative. Whereas if you had another one, they're both positive, so 2 positives multiplied together is going to give you a positive. So if your power is even, it will be a positive value. If your power is odd, it will be a negative value. Okay? And then we just need to multiply these two big numbers together. We want that.
Oh. 1, 7, 7, 8, 1, 2, 2, 7, 5, 2.
Got it? And then what's going to happen with these two things? Because they're the same base.
Aren't you gonna have to remove the
Possibilities, yeah. So what do we do with it?
30 minus 6.
Yeah, so essentially we're adding these two powers, yes? Or in other words, just 30 will take away 6. So that will be x to the power of that says 24. Alright, so you may be able to expand one expression and then use this to complete a further expansion or find a term of further expansion. So, here we go, expand, blah, blah. So, we've got to expand. Do any of you?
Yeah.
No, it's called
Alright.
down.
So, we're going to expand this bad boy, and we're expanding the whole thing. So, this let's try again. Okay, so A in this question is 3, B is 1, N is 4. Yeah, 4. I'm not writing it. What's our Pascal triangle row?
1, 1, 1.
1, 4.
4. The 10. 10.
4.
10.
1.
Huh?
Okay, so remember this is the line that I was hoping you were going to remember
Yeah.
to help you with all the others. So we've got that stuff. And if we were doing a group exam, we'd be sorted.
Why don't we do that? Like the orals that we have in English, like a group oral. Why don't we do that?
They don't mind getting in trouble.
No, but you should just add it in the curriculum.
Okay, sure. So that's our row we're remembering. So there are values in the front. So we've got 1 at the beginning, and we've got 3 to the power 4, and then negative x to the power 0. Remember this? Just going back to the very first lesson. Plus 4, and then it would be 3 to the power 3, because we know they go down by 1 each time. And then negative x to the power 1. And then plus 4, 3 to the power 2, negative x to the power 2, plus, oh no, this should be 6, sorry. And then 4, 3 to the power of 1, negative x to the power 3, plus 1, 3 to the power of 0, negative x to the power of 4. Ooh, that's good. And then obviously we need to work out and simplify those values. And so this is quite likely to be on a non-cap paper, this kind of question, because we haven't needed a calculator at all here. It's a nice low value for n, so we can easily remember Pascal's triangle for that row. Well, it's easily. And it doesn't take very long to just write that bit out. Okay? So 3 to the power 4, you would be expected to try and work out something like that. Powers of 4, sometimes it's easier to remember that that's going to be 3 squared multiplied by 3 squared. Sometimes that helps. Yeah. Obviously these two terms are both 1, so that's going to be 81. 3 cubed. Yeah, so 27 multiplied by 4. And sometimes people are like, well, I can't do that without a calculator. Just write it. 27 multiplied by 4. Yep, 108. And then we've got negative x to the power 1. It's an odd power, so that means our term is going to be positive or negative. Negative. So secretly I shouldn't have written plus here. Apologies. Yeah.
Do we have to go over to it doesn't work.
Yes, because they didn't say the first 4 terms, they want the whole expansion.
Okay.
Yeah. Right, next one is this. This one is 3 squared is multiplied by 6.
9 times 6 is 54.
Notice I haven't put my sign in here, so that's 54, and then I've got negative x, and that's being squared.
So it's going to be even.
So it's even, so it's a plus, and then that's going to be x squared. Yeah?
Yeah.
So then we've got 3 to the power 1, which is 3 multiplied by 4, which is 12. And we've got a negative, and it's power 3, so this is going to be a negative x cubed. And then 1 is obviously 1, 3 to the 0 is obviously 1, and then we've got negative x to the power 4. So it's going to be plus x to the power 4. Alright? That's it. So again, that wasn't too traumatic, it didn't take loads of time. So it is, as I say, likely to be on the non-cap paper. Now, whilst that one wasn't too bad, lots of people get to this next one and go, what the heck are they asking us to do now? This is ridiculous. However, it's really, or it shouldn't be, as tricky as you might think. What we need to do is we need to appreciate what's actually happening here. This is what we just expanded. Yes? Now, sometimes the exam pressure gets to people and they think it's a whole brand new question and they start doing something crazy. If it's an A and a B, check to see if it's related to that first bit. Okay? Because it's going to save you a lot of time. I've seen so many people redo the question and stuff like this. And it's just time that you can't afford to spend on. Now this term here is all on its own, but it's got the x on the bottom. So first thing I would suggest is to rewrite this bad boy with the x as a power. So how would we do that?
It will be x more to the power of
So it would be 1.
1 2
X to the minus 1, yeah.
Oh, I got
Yeah, you're happy with that?
Yeah.
Now, if we were to expand this, right, we've already got this expansion from the bracket. So if we were to then expand this or multiply this by this, then each of these terms would be multiplied by each of these terms. Yeah? Now, you could do that, take a little bit of time, and you don't necessarily need all of them. Because all they want is to find the term that's got x squared. Okay? So you've got to be careful here though. Okay? Because there's an x in this bracket as well. So if you were to do this, or if we multiply them all by 1 first, is that going to have x squared? No. Is that going to have x squared? No. I'm still pointing on this one. Is this one going to have x squared? Yes. Okay, so we're going to have 54x squared as one of them. This multiplied by 1? No. This multiplied by 1? No. Okay, right, now we need to do this term multiplied by everything. So this multiplied by this? No. This multiplied by this? Well, what happens with this x and this x to the negative 1?
No, that'd be negative.
Well, this is a secret power of 1. So you've got a 1, and then you've got a minus 1. So it becomes 0. 0, yeah? So that's disappeared. So when we do this one, multiply by this, we've got the 2 plus negative 1, so that becomes to the power of 1. That's still not what we want. So when we do this one multiplied by this, what happens? We get an x squared, yes? So all we need to do is multiply by this now. So we've got negative 12x cubed. Should we write it? Negative 12x cubed multiplied by negative 2x to the negative 1. So negative 12 multiplied by negative 2 gives us, yep, and then x cubed multiplied by x to the negative 1 gives us x squared, hopefully, because that was why we chose it. You with me?
Yeah.
And so that meant we had 2 terms that have an x squared. So our final step is just to join those together. So obviously we would add them. So that would be 78x squared. So the term with an x squared in that expansion is 78x squared. Now, so the important thing here is, can you see how you need to not waste time when you're doing this? Alright, so you need to try and find shortcuts. If you are less confident with your values when there's different powers of x's, then sure, write each of the terms multiplied by this second one. I mean, multiplying everything by 1, I'm sure you're pretty fine to determine whether it's got an x squared in it. When it's got this here, it's a bit more complicated. So maybe write each of those out, that's fine, but you need to make sure that you're not spending too long doing these kinds of things. And you're especially not repeating what you did up here, down here. Again, sometimes I've had people do it wrong up here and do it right down here, or vice versa, and then it's all going to go in my entire market because it's supposed to be a carry through. Okay? Good? What's this bad boy? So another couple of exam questions. So consider the expansion of the verb. Write down the number of terms in this expansion. So it's only got 1 mark. It's going to take you less than 1 minute to do it, because how many terms are going to be in this expansion? Why? Right. Very simple. Right, find a term containing x squared. So this is where we go back to our original expression. We've got x plus 2. Do both of them contain an x? No, so it's just this first term contains an x. So that's the only one we need to worry about having a power of 2. So if we look at our general formula in our, I'm going to write x to the n minus r and 2 to the r. You happy with that? Shall I change the n to be an 11 already? Is that right? Have I rushed that? Right, so we want the term containing x squared. We're not interested in this, we're not interested in this, we're just interested in this. So which value of r are we looking for? I want a general consensus. 9, yes, you happy with that? The reason being is that we need this bit to be a 2, and so that means that R has to be 9. So we're now looking for the term 11, 9, and x to the power of 9 to... That's not 9, it's 2, isn't it? 2 to the power of 9. Now, I don't know whether this will be on paper 1 or 2. Let's say it's on paper 1. Okay, so we're in this situation here. We need to find out this value. So you can either draw Pascal's triangle. That's what the other method that we can do, because we only got one term. It may be worth doing the factorial business. Yes? So if you remember, that is n factorial over r factorial n minus r.
Yeah.
So ours is 11, 10, 9, 8, 7, over 9, 8, 7, and 2 times 1. Okay, I got really lazy there, but I really didn't write those numbers. And why didn't I want to write those numbers? I do now. Cross them out. So from 9 down there, I'm just going to pull those factors out. And what else can I do? Oh, I'm going to focus on my 2 and my 10, yes? So I'm going to get rid of that, and that's going to become 5. And so on the bottom now I've just got 1, and on the top I've just got 11 multiplied by 5. So I've got 55. Yeah? So this is 55, x squared, and then 2 to the power 9. We should be able to do that in our heads. It's a big number. Let's just double it up. I don't know what the answer is. 2 to the power 5, I know it's 32.
It's 3,
You just make it look like what, 2 to the power 9 isn't going to end in a 5.
I just want that. It's 5. That one.
Okay. And so 2 to the power 6 is 64, 2 to the power 7 is 128, 2 to the power 8 is 256, 2 to the power 9 is 512. And then obviously our final step here is we've got 255 multiplied by 512. Oh gosh. Well, remember we would make sure you can do that without calc. But what is it? 2A160. Okay.
Love it. Love it. Love it. Thank you, Malai. So yeah, so just be careful when you're rewriting this bad boy. So that's x to the -2. I'm just being fussy here. Perhaps don't write this where it well, no, I guess it's fine. Shut up, Miss Harrison. You're being fussy. Okay. So yeah, yep. The next one, did you say?
Yeah.
Oh, yeah, sure. Okay.
Alright, okay. So this is not any different. So we're going to first of all rewrite this. So this is 3x squared minus 2x negative 1. Yeah? That's all to the power 5. So that's our first step. And we want, so A, in this case, is 3x squared. Excuse me, B is negative 2x negative 1. N is 5, so we need to establish the value of R that we need. So it's 5R, 3x squared to the 5 subtract R, and then negative 2x negative 1 to the power R. This is where we focus on just the powers of x. So if I'm focusing on the power of x for this part, it's going to be x to the power of 10 minus 2r. Yeah? And then this is going to be x to the minus r. again, I'm ignoring the numbers just for now, but I'll come into play in a minute. So then you've got 10 minus 2r, and then you've got minus r, so that becomes x to the 10 minus 3r. And we need that value to be what? 4. So then we've got 10 minus 3r has to be 4. So 10 subtract 4 is 3r. So it's 3r, 3r is 2. And then that's, we go back in here, and that's what we're finding. So we've got 3x squared power 3. Negative 2x minus 1 is 2. So looking at the letters still is just confirming or denying whether you've done it right. Really, you should just be able to focus on the coefficients, but it's up to you. So 5, 0 I know would be 1, 5, 1 would be 5, and then the next number, do you remember the 5 one? It's 10, yeah? So this value is 10. I need 3 cubed, so that's 27. And so as I said, you want to just double check that with the x and 6. But you've got negative 2 squared, so that's positive 4, yeah? And then x to the negative 2. And when I join these two together, that does give me x to the 4, which is what I needed, thankfully. And then you've got 10 multiplied by 27 multiplied by 4. So you've got 270 multiplied by 4, or do the 27 multiplied by 4, so that's 108. And so that's 108